In this skill, we're going to be putting together what we know about alpha, beta, and gamma decay with writing nuclear equations. So in this question, we're told we start with a strontium-90 atom and that it undergoes beta decay. So first, let's remind ourselves what beta decay means for our strontium nucleus. Beta decay means that a neutron turns into a proton, which remains in the nucleus, and an electron and an antineutrino, which are emitted. So that's what happens during beta decay. And in this process, what's emitted? An electron and an antineutrino are emitted. So our goal is to write the full equation for this process. So we know we're starting with strontium-90. Let's head to our reference sheet to have a look at our periodic table. Let's find strontium. Here it is. Strontium has the symbol SR and it has the atomic number 38. So we're looking for the symbol SR and the atomic number was 38. And we're told in the question it's strontium-90. Remember, that number is our mass number. So we can go ahead and fill that in our top box, which is the mass number. Now we need to apply our knowledge of beta decay. So we know a neutron is going to turn into a proton, which remains in the nucleus. So that's going to help us determine which atom strontium-90 becomes. So we're starting with strontium, which has 38 for the atomic number. That means 38 protons. It has a mass number of 90. So 90 minus 38 gives us 52 neutrons. And now we know that one of those neutrons is going to turn into a proton, which stays in the nucleus. So we're going to end up with one less neutron, so 51 neutrons, and one more proton, so 39 protons. So let's head back to our periodic table and figure out which atom has 39 protons. In other words, an atomic number of 39. And here it is. It's yttrium, which has a symbol Y. So we've got yttrium with the symbol Y. You can go ahead and fill that in now. We've got yttrium. Our number of protons is 39, so that's our atomic number. For our mass number, we've got 39 plus 51, which is 90. So we'll notice here that the mass number doesn't change. That makes sense because a neutron's turning into a proton, and the mass number is the total number of protons and neutrons. So that doesn't change even if a neutron turns into a proton, but our atomic number has changed. It's gone up by 1 because we gained a proton. Now for the rest of our equation, we know in beta decay, we also emit an electron and an antineutrino. So firstly, choosing our symbol here, beta, that's our symbol for an electron. And we know it has 0 mass because it's got no protons or neutrons. But for the atomic number, we put -1 to signify that it has a negative charge. And we emit an antineutrino, which has this symbol, looks like a V with a bar on top of it. And that has a mass number of 0, showing it has no protons or neutrons, and an atomic number of 0, showing it has no charge. So there we've successfully written our equation for this process. Finally, we need to write down the name of the atom it became. We know that Y is yttrium. And we know that the mass number is 90. So strontium-90 became yttrium-90 in this process. We'll do one more question of this type. In this question, we have dubnium-223, and we're told it undergoes decay to become lawrencium-219. So let's head to our periodic table to figure out what those elements are. Here's dubnium. It has an atomic number of 105 and the symbol Db. So we can fill that in here. The symbol is Db. the atomic number was 105. And we know our mass number is 223 based on the fact that it says it's a dubnium-223 atom. We're told it becomes lawrencium-219. So looking on a periodic table, here's lawrencium. It has an atomic number of 103 and the symbol is Lr. So our symbol is going to be Lr. Our atomic number was 103. And we know from the question our mass number is 219 because we're told it's lawrencium-219. We now need to go ahead and complete our nuclear equation. So the total mass number in the reactants has got to equal the total mass number in the products, and the total atomic number in the reactants has to equal the total atomic number in the products. So we start with dubnium, which has a mass of 223. That's the only thing in our reactants. Then on our products, we have lawrencium, which has an atomic mass of 219. Plus we have an unknown nucleus here. So I'm going to label that with an M for our unknown mass. So 219 plus M. Then for our atomic numbers, we've got 105 on the left, and that's our only thing in the reactants. And then on the right in the products, we've got 103 for lawrencium. Plus we have our unknown, I'm going to call it A. And those are going to be equal for both the mass and the atomic number. To get my mass number, I'm going to do 223 minus 219, which gets me a mass number of 4. And for my atomic number, I'm going to do 105 minus 103, which gets me an atomic number of 2. So we can go ahead and fill that in. Mass number is 4 and our atomic number is 2. So what is the name for this nucleus? Well, it's got 2 protons and 2 neutrons. So that's a helium nucleus, otherwise known as an alpha particle. Awesome, so we figured out our equation. Now we need to figure out what type of decay it is. It's pretty obvious here since we have an alpha particle produced. This one is going to be alpha decay. To describe what happened in this process, we had our nucleus losing 2 protons and 2 neutrons in the form of our alpha particle. So the answer to that question is going to be B. And the thing that's emitted is a helium nucleus, in other words, an alpha particle consisting of 2 protons and 2 neutrons. So in these questions, you're combining your knowledge of alpha, beta, and gamma decay with your knowledge for how to solve a nuclear reaction equation. Remember that the mass numbers on the top in the reactants have to equal those in the products, and the same with the atomic numbers, which are on the bottom in the reactants, have to equal those in the products.